Hello, everyone. My name is Nicolas. I'm a solutions architect at AWS, and today I'm going to talk to you about something that's a bit personal. So I joined AWS about 2 years ago. In the meantime, I've been talking to over 1,000 technical people, developers, ops, DevOps, cloud architect, and all kind of different roles there. And in many cases, for some reason, maybe just by pure coincidence, I get involved in right as they are doing the DevOps transformation, when they are moving to microservice, when they are restructuring their company, when they are moving to the cloud. So this talk is kind of a journey based on all these discussions that I had. And to start off, I was talking with a developer about the idea of owning the release, that developers own the release and so on, that they also own the monitoring, that they would be responsible in some way for maintaining the application running. And the first reaction from that person was, does this mean I have to be on call? And I could see on his face that he was quite worried about this. I didn't think much about that. And I just thought, yeah, that's a very good idea. I mean, the best person who knows how the software operates is the person who built it. It's the developers who build it know the ins and outs. So that's a very good idea. You should be on call. But I could see that that person was still very worried. And that's just not one person, something I've seen in different occurrences. So I'll start, and through the talk, I'll sprinkle a bit of ways we work within AWS. One of these is called the 5 whys. The principle is fairly simple. It's just asking whys 5 times. And it should help you get to the root cause. If you do that correctly, it should help you get closer to the root cause of the problem. That applies for operations, trying to find performance issue, trying to find what's broken and so on. But it also applies in this case to people concerns. So first question, why are you concerned with being on call? And the response was, I don't want to wake up at 3 a.m. every week. Well, that's a bit odd. I mean, why would you have to wake up at 3 a.m. every week? And the answer from the developer was, well, because there are alerts every Thursday at 3 a.m. Well, that seems odd. I mean, what causes alerts every Thursday at 3 a.m.? Why? Could you explain to me? And his answer was, because Wednesday evening is release day. That's when we update our solution. Well, why do release trigger alarms? That's kind of odd. Once again, I mean, maybe once in a while you have something that fails, but that should be, and hopefully you should have a good pipeline that mitigate that. Well, his answer was, because deployments always break something. And the last question here, why do deployments break things? I'm just going to take a bit of a step back there, because depending on who you talk to, it's going to be a bit different. Just a quick show of hands, who's consider themselves more on the ops side? Who consider themselves more on the dev side? So depending on where you are, you might say something different. And dev people will say, oh, it works on my machine. I mean, I'm running it on my laptop, works perfectly fine. The ops is doing something wrong. I mean, the instruction I put in the Jira ticket were very clear in terms of how to deploy that. And the ops will say, well, they are making some change that's breaking the build. They're doing something wrong here. And often, it's not a matter of who's right, who's wrong. Sometimes it's one, sometimes it's the other, but it's also mostly a communication issue. And I also take the chance there to talk a bit more about myself. So as I said, I joined AWS 2 years ago in 2017. But before that, for 6 years, I run my own company. I was managing a team of 15 people, both developers and ops. Kind of made lots of mistakes, one of which resulted in me having to close the company. On the other hand, I'm here today. I'm work for AWS, which is quite amazing to be able to come and talk to you people. And so now, on the AWS side, I started this month being a startup solutions architect. Before I was working with other types of customers. And I'm there to help them design infrastructure on AWS and also prevent them from making the same mistakes I did. And quick side note, I'm also serverless subject matter expert. It will come a bit handy a bit later in this talk. So, when I take a look from my experience managing people, I have this ops team, I had this developer team, and development manager and operations managers, when I start to talk to the companies that are structured this way, you often find the same patterns. The people that are that preoccupied by the product development, software development manager, they want to ship things. They are measured on the new features being shipped. It's what's important for them. And the operation managers, well, what they want to do is keep the lights on, increase the SLA, maintain the SLA, increase the uptime, trying to reach that 1 more 9 of uptime, trying to reduce latency and so on. And if they don't meet the objectives, well, for the developers, missing to build new features, well, you lose the competition because you're not able to innovate fast enough. You might have a new company that comes and disrupts you. Or if the simply put is not working, well, you end up with angry customers. All good for the screens? Good. Can you see the screen over there? Yeah. Okay. Thank you. So, no. It's working? Okay, perfect. Yeah, this screen just popped back into life. So if your product is not working, you're going to have angry customers. They're going to ask you, why are we paying you? So in the end, the outcome is kind of the same. You lose business. So based on that, I started thinking, and that's something I applied in my own company that I've seen also applied by other companies as well, just to think about the way you structure a team a bit differently. And the idea is to have product or service teams and a tooling team. And I'll come into what the tooling team or tooling teams does or do. So the product team are the ones that are responsible to build the new features, and they're also responsible for owning the maintenance and operation. They own the entire life cycle of the product, microservice, domain, and so on, depending on how you split, depending on what's relevant for you as a business. In the case of my previous job, we also included customer advocates. So people whose responsibility was to be the voice of the customer, to make sure that we were not steering off course, that the product teams were building the right thing that were useful for customers. And one thing also in these teams is that it's not just developers, it's kind of a mix of resources, it's kind of a mix of talent to bring what's useful for that role. And then, for example, for the dev, we had dev leader who was responsible to maintain, make sure that devs had the best practices, increase, learn new things. But when they were talking about domain, product, service, and so on, it was really a team that was working together, a cross-functional team. And then you have the tooling team, whose role was to share best practices, create quality of line tools, and mainly enforce quality across the organization. So if you are working in security sensitive or regulated industry, that team will build tools that make lives easier for other people, for the product teams to build products that are compliant, for example. And on this idea of product service team, going back to the AWS kind of way of working, if you haven't already heard, we have a concept that's called a two-pizza team. The idea is that if you can't feed a team with 2 pizzas, that the team is maybe too big. So AWS is an American company, so these are American-sized pizzas, because European-sized pizzas would not fit usually more than 2, maybe 3 people if they're not that hungry. And it's an atomic team that work on the same goal, they have the same objective, they are free to make decisions and gather the data, contact customers to support their ideas, and they're responsible for the outcomes as a single unit. So they have the autonomy, but they also have the responsibility of that autonomy. So the question about why do we want to limit the size to something that can eat 2 pizzas, that's roughly 8 people on average. It's a matter of communication with people. the more people you will have, the harder it will be to communicate with each other. So here you have these three graphs of people talking to each other. If you have a team of 3 people, you have 3 connections. It's really easy to know what everyone else is doing. 6 persons, you have 15 connections. It still stays fairly easy. If you have a Slack channel for your team, you can still communicate and know what everyone else is doing. When you get to 12 persons, the number of you see that the number of connections just keep increasing and increasing. It becomes harder and harder to maintain cohesion and to be aware of what everyone else is doing. Having these small teams, making so that if you are working together, you know what the other ones are doing all the time. And so just for reference, that's the kind of the graph that you see. As you see, it grows exponentially there. At 16, we're already over 100 and maybe a bit shy of 120 connection. So that becomes really hard to communicate effectively. At some point you want to split. So one thing here, we're at a tech conference. I just kept talking about people for the last 15 minutes. And it's kind of something that I feel is really important. Conway's law is one of the things that I probably talk about once or twice per week at least, which is the organizations which design systems, which should be most of the people here today, are constrained to produce designs which are copies of the communication structures of these organizations. As in, if you have an operations team and you have a dev team, well, your infrastructure, the way you split it, will be based kind of on these responsibilities. If you don't have good communication between the developers and the operation, you will have a gap between what they build and the infrastructure underneath it. And that's something to think about. And for that, there's actually something called the reverse Conway maneuver, which is if you want to adopt a DevOps approach, if you want to move to microservice and so on, think about whether or not you need to restructure the organization, what changes need to be done sometimes in the organization to promote the desired architecture. And the way I've shown with this product team and tooling team is one of them. And I think when we think about DevOps engineers, have a few friends, and I've met a few people with that title, ask them what they were thinking about their role. And yeah, they were saying themselves as a team that enables the rest of the organization to build things and be able to own the things that they build. Kind of a you build it, you run it kind of way. So, how does it work? Or how does the tooling team work? There's kind of 2 ways that I've seen in the wild. So when you have people that start moving to microservice, that start to transform the organization, that move to the cloud and so on, I've seen people taking 2 different approaches. The first one, I'm going to call them gatekeepers. It's not as a bad thing. Gatekeeper doesn't mean that it's a bad thing to do. There might be some really good reason to do that. And so the gatekeepers provide a layer. And that's the sole way to interact with the infrastructure. So the infrastructure is going to be much more opinionated by that team. Developers won't have as much flexibility to build what they want to do. And that enforces compliance and best practice, which if you work in a regulated industry, you want to have some kind of way to enforce that. You want to give developers some level of freedom so that they can do things, experiment and innovate. But when we got into production, it has to be compliant with our regulation. So there, it will limit the innovation because you can give a gated garden to the product team. For example, you can only release containers. You cannot use the other services that are available on AWS. We provide you a way, we provide you a pipeline, and you just release the container. On the other side, you have what I would call the framework builders. So there it's the tooling team will be a team that build tools, build frameworks, and so on, that's enabled to start with best practices, but there's not as much control in terms of ensuring that the best practices are followed. So going back to the example with the regulated industry, well, now it's the product team's problem to make sure that they're compliant when they go into production, that they have the burden of proof to show that it's compliant. And it's also, as you can see, it's also shifting the responsibilities between the two. And the right answer for you, if you are, it's kind of food for thought depending on how you work today. Probably somewhere in the middle between the, think about the trade-offs of the two approaches. Because it's a spectrum, actually. And I'll show a bit of some architectures I've seen, and that I think are interesting to look at when you think about the way to build that. So when you're on the gatekeeper side, the tooling is really the tooling team's responsibility to build the tools and enable the product teams. And you also restrict the flexibility because the product team can only use what the tooling team has built for them. So if you build a framework that enables them to deploy containers, they can only deploy containers. They cannot deploy something else. You need to build another tool that allows them, or you need to build that flexibility yourself, which means more ownership there. But it's actually for organizations that come from a large gap between dev and ops, where developer was used to ship things over the wall and throw it at the ops people. That's actually a pretty good way to get started. The learning curve is much shorter for the developers. And I've seen some companies using an approach that were more on that side. And developers then get really interested into learning about Docker files and containers and starting to experiment with that. Might end up that as time goes, they will start to want more and more flexibility and more using the platform more and more. And so, of course, then since it's a spectrum on the other side, the framework builder, well, the tooling team does much less. Much more burden is put on the product team. And also much harder for the product team to get started. So if you have, again, this wide divide between dev and ops, it's going to be really important that in the product team, you have people that are able to understand the infrastructure underneath it, what's possible, what they can do, so that they can leverage the best out of it. What I've seen some companies that are on that side of the spectrum is that they will have lead engineers who are there to recommend, and sometimes the tooling team, or you could also the CCOE, Cloud Center of Excellence, which would be people that are there to enable the other teams, share best practices, and help them design it in a cloud-native way. So let's look at a sample structure where you have the product team wanting to build their product, the tooling team that on the underlying base infrastructure, and we have our staging and our prod environment. So staging, replication of prod to do our tests. So this could be on AWS CloudFormation stacks, or going one step further, this could be separate accounts. Depending on your size, it could be good to have separate accounts because then you completely isolate from a security perspective. You need to grant explicit access between staging and prod, which you should never do when you have separate accounts. And also, the account limits don't interfere with each other. You don't have the risk of having a runaway problem in the staging environment infecting prod potentially because of service limits. So now if we want to have pipeline, actual reproducible changes and so on, same thing once again can either be a CloudFormation stack or that could be a separate account. Where you have the CI/CD pipeline. And the CI/CD pipeline would automatically deploy to the staging and to prod. And so what the product team does, they push the code, the CI/CD pipeline pick up from some kind of Git repository, GitHub, code commit on AWS, and so on. Then there's another thing which would be a separate, and I would recommend having an account here for security reason, a separate account with the logs, backups, and so on, that the product team can read so that they can inspect when something goes wrong. And you ship the log from both staging and prod over there. But that's the reason why I would recommend having a separate account is that if there is any kind of security vulnerability that compromise your AWS account, so let's say leaked AWS credentials, your user access key and secret key are leaked, well, you still have all the logs. You have, for those who are not too familiar with AWS, we have a service called CloudTrail that logs most of the API calls that you are making on the platform. So if someone compromises access there, you would have all the API calls being tracked and logged. So you can see what happened, and you can start doing some investigation, understand how to fix it. And having the backups in the separate accounts allow you to just respin up the architecture if the worst come to worst. And so here the tooling team would manage the CI/CD pipeline and the logs, backups, and so on to restrict the product team. So that would, on the CI/CD side, that would allow the tooling team to enforce some kind of standard on the CI/CD pipeline. They run the pipeline, they configure and deploy the pipeline for the product teams. So they can also enforce, as in if you need to do some security checks, you can do them in the pipeline in a way that the product team cannot modify. And same logs, backups, they're also responsible for managing that. And then last thing that I find is quite important is having a playground access to environment. Is just the ability to for the product team to do some experimentation. So if you go more into the framework builder route where people have more access, they can experiment with things, as in we need to do some kind of we need to build image recognition for our service. AWS has a service called Recognition. Can we try that? Does it work? Does it fit our needs? We can experiment in that environment. And there they have full access. They can also, each developer can also spin up a production, a replica of the production service, such as that they can test and experiment there as well with new features. And finally, they would have read access to staging and prod, so that they can also see when something, every change is done through code, through the pipeline, but they can inspect the staging and prod environment when something goes wrong to try to understand. So of course there are some cases depending on how you build. Worst come to worst, there might be some times when you need to do manual intervention. You could build a system that allows the product team to get temporary write access to be able to debug something, for example, in the staging environment, repair something there. So going a bit deeper into that, so the CI/CD pipeline ideally should be owned by the tooling team, at least at first. So this remark there stems from a discussion with a colleague of mine who used to be kind of a DevOps advocate at one of our customers. And he saw his job as having an experimentation date. As in, at first, he helps people set up, create them, ensure that they don't make mistakes. But as they get more confident, just shift the responsibility around, give them ownership over the pipeline so that they can customize it, they can decide what they want to do forward, because they've built that expertise. So the product team interacts with it through Git, and then you can perform security testing in the pipeline, and you can also create a pipeline vending machine, which is, so we have a service called Service Catalog, where you can allow, in this case, product team to deploy resources, deploy CloudFormation stacks. And so that could be used to deploy a pipeline, and a vended pipeline, as in a pipeline that you have a certain level of control over how it's configured and how it's built. Going into the pipeline, so here I'm going to use AWS services, just because I work for AWS, so it's easier, and it's services that I use on a very frequent basis. So just to go over some of the services for those who are not aware. So code commit here is for Git repositories. Code builds provision a container image when you can do build and test. Lambda is our service for running serverless functions, so for running code on a request based, and CloudFormation to deploy infrastructure as code. So in this pipeline, as you can see, I've put this bar here on the top to see a bit where we are on that spectrum. The product team has some flexibility. Code build use something that's called the build spec file. So that's a YAML document that says exactly the operations that have to be performed in code build. And in this case, they control that. Now, when I put things in red, it means that it's owned by the tooling team. So the security test for Lambda would be performed by the security team in this scenario. which means that they can do check like vulnerability testing, making sure that your dependencies are up to date. Otherwise, this Lambda would fail the pipeline and would not allow it to move forward. Or you can do analysis on the CloudFormation stack, on the CloudFormation template, and say, oh, you're opening port 22 to the internet. We don't allow that. And then next stage, CloudFormation does deployments, and then once it's deployed in a staging environment, there the product team gets back the ownership. They can run, for example, a Lambda function that can do test against the infrastructure deployed to do end-to-end test within their product or service. Or you could have a manual approval step there. And once they're happy with that, then CloudFormation could deploy to prod. And as you can see, these two little icons with role in the pipeline. So for deploying the CloudFormation resources, the pipeline will assume a role, and you can then restrict what's possible to do. You could restrict, you can't deploy the biggest EC2 instance possible. You cannot use this or these services, for example. So you can set up some restriction there to limit what people can do. And if we look more on the gatekeeper side now, so same kind of principle, but now it's going to be more restrictive. So here the pipeline is more managed. First of all, I replaced CloudFormation by ECS. So this way, the Elastic Container Service, so the team can only deploy containers. The code build specification is static, cannot be changed by the developers, by the product team. Therefore, it has to follow this build process. So that reduced their freedom, but that also means that it's easier for the product team to get started. Same security test and product test there haven't changed. Now if we look at the infrastructure, so when we had this first pipeline, the tooling team can provide a staging or production account that has a baseline. So the baseline would be some security setups, some restriction to make sure that it's compliant with the security rules of the organization. So I already mentioned CloudTrail for that, to log the API calls that people are making to ensure that there is no security threat. AWS config is a service that you can define. There's some managed rules there, or you can define your rules in terms of what is compliant. I mentioned the case with port 22 being open to the internet. Well, you could have that as a config rule here. And so if that is violated, that could trigger a notification or trigger an automated action with Lambda as well. And then you have guard duty to do some analysis against common threats. For example, one of your EC2 instances is behaving in a way that's very similar with Bitcoin mining, or in a way that's very similar with DNS data exfiltration, for example, and that can set up alarms or automated action as well. And finally, Security Hub, that can integrate with the findings from guard duty, but also third-party partners, so that you have one place to see all the findings there. And then for the product team, they have this box with CloudFormation. So they provide the CloudFormation templates, and there they have the freedom within the constraint that you can put for the IAM role in terms of what they can or cannot deploy. If we look in a more controlled environment, there the same baseline is there. I would recommend at least you have a look at these services if you are not using them already. But then the tooling team could already provide a database. Let's say everyone use RDS MySQL. That's the rule that we have. The ECS service could be set up already to send logs to CloudWatch, and you already have the load balancer configured in front of it or something like this. So that's kind of what you can put in terms of restriction. But these restrictions make also, when you have this big gap between dev and ops, makes it also easier for them to get started. But this has a big problem. If you end up with product teams that are very curious, and I've seen that quite often, is that they'll start looking at the rest of the AWS infrastructure, the rest of the AWS services that exist, and then they might find something really nice for their use case, but they cannot use it. So going back to my example with recognition, well, in this case, you can't really use that. So that's a trade-off to be aware of here. And so just a few more examples that I've seen from customers. So in this case, I've seen a few customers do that where what the tooling team does is that they provide the API. We have a service called API Gateway, where you can provide a Swagger or Open API definition. And you can take care of authorization. You can also take care of throttling. You can provide API keys through that service. And so you can have the tooling team just taking care of the authorization and throttling. And then the product teams just build whatever's behind it, that API. But they don't have to think about the way you do authorization for your product. Even though you have different microservices, you have one common authorization pattern and so on. I've seen that quite a few times. And that solves some concerns around making sure, if you want to make sure that the product team are actually implementing authorization correctly. Or really on the other extreme, the tooling team could just provide a service that build accounts and the product team have access. There is a security baseline that's mandatory, but then that's it. Then the product team are free to do whatever they want within that. That requires a high skill level from the product team because they should both be able to build the product but also leverage and know how AWS works ins and out to leverage it as much as possible. And based on that, you see, I mentioned a few things such as how Dev and Ops are working before the beginning of that transformation journey. So there is a website that I really like called DevOps Topologies, and it lists anti-types and types of way of working in a DevOps way, because they're not just one way that works for everyone. It really depends on how you work as an organization. Are you single product? Are you multi-product? How large are you? That's going to influence a lot how you're going to work. And if you're familiar with that website, you might be wondering, actually what Nicolas is saying looks a lot like some of the antitypes that are there. And I'm going to use that as kind of a warning sign if you're thinking about that. So antitype D on that website, so DevOps as a tooling team, where the organization is building a team to do DevOps, build tools and so on. So similar to the tooling team I mentioned, but software is still thrown over the wall to an ops team that just need to manage it. So yeah, developer gains some quality of life enhancement and so on, but they're still not responsible for operation. They're still not responsible for maintenance and uptime and so on. So you still end up with the same problem. It's just easier for developers to build things. And then you have another one, which is anti-type F, where it's ops embedded in dev team. So I mentioned having ops people in the product team. So it is a multifunctional team. But in the anti-type here, the issue is that the ops people are not empowered. As in, the focus is still, the metrics are still the same. It's still ship features and not ship features that work. And that kind of boils down when you start thinking about shifting from just building features, business features, to having a team that owns the entire thing about what is the definition of done. Is the definition of done just what brings business value? Because as builders in general, prefer kind of the term builders there, we should bring business value in a sustainable way. That's kind of our role, is to help the business go forward. But the sustainable way is very important and sometimes can be challenging to understand, especially by non-technical people. So that's kind of, there might be many more things that you want to add. Maybe something are not as relevant, but I consider that a pretty good baseline for considering if something is done or not when you're building a new feature. So first of all, business. Always get back to the business. Does this meet the user's needs? And can it be profitable? Because you can build a new feature, but this feature might cost $10,000 a month and bring $1,000 in revenue. While it's not a really profitable feature, is it? And then, is it maintainable? Is it properly documented? Do we understand how it works? What could go wrong, kind of thing. What are reliability requirements? that's actually something that's thinking about SLAs, having service level, microservice level SLAs, as in we are expecting this uptime, we're expecting this maximum P99 latency, for example. How do we meet them? What processes have we built to ensure that we meet that? Are they enough? Are we actually going too far as well? Is it not cost effective anymore? It goes back to the business case. What's our performance requirements? So yeah, that P99 latency. What do we do to meet that? What is our threat model? More on the security perspective. When we build that feature, when we build that new microservice, what are the risks? Who are our potential attackers? What's interesting there? What would really cause damage to the business? What did we do to reduce that risks? Did we do enough? Or is there things we can do? Is there things that we can't do today, but we need to think about it in our roadmap for all these things? What will break first at scale? So, as I mentioned at the beginning, I'm a startup solutions architect. So for me, I'm always concerned about how things will scale, because I hope that most of the customers I interact with are going to grow 100 times at least. It's not always the case, but it's good to have an understanding about what will break first. Will it be the database? Will it be, is there any kind of state stored in the application layer which make it hard to scale horizontally and so on? How do we mitigate that? Is there some way to mitigate that? Is it a problem? What is our, I would say, best case scenario from the business perspective, but worst case scenario from the operations perspective in terms of traffic? Because you have cases as well where something will become viral and as part of the business where you don't have that much traffic, then it will increase 100-fold. What do we do to be ready around that? Can we predict that? Is there anything external we can monitor? Thinking about that, it's kind of also thinking about outside the box, as in we can monitor Reddit, we can monitor Slashdot and other websites to see when something is trending, if it's something that's a common occurrence. And finally, can we change things? How easy is it to add new features, change architecture, like if we made a bad decision? Going back to the AWS bits, we have something that we call two-way door versus one-way door. A one-way door decision is something that's going to be hard to change afterwards. And we're trying to stay away from that. It's better to keep the door open, because maybe we're wrong. And it's good to admit that we're wrong. And so that's kind of, these points in red are where the tooling team and also the infrastructure, so the cloud provider are there to help. And then these in orange are kind of where the concern of the product, the software architects are. But all of that is important in the definition of done for me. And so going into this model, that's kind of the route I've seen, the journey I've seen some of our customers take. So where they get started with that kind of model, they get started with their transformation journey. The tooling team is really involved at first. So here you have the operational responsibility during this different stage. Well, the tooling teams is the one that manage the most operations. And they slowly build the confidence from the product team. So training developers, helping them, shifting things around. The company might be restructuring. Then they build confidence and so on. One thing I've seen quite often is actually where it brings to the curiosity of people that are actually building the systems. They start to look at what AWS does. They start to look at the services we offer, the managed services. I mentioned recognition as being one of them. Kind of, is there some way that I can do that just faster and not having it to manage myself? Because the more AWS manage the infrastructure for me, the less I have to do myself, the less going back to this thing, in these red points, these are not unique to a specific business, except defining what's acceptable or not. And so if there's something that can be shifted to the cloud provider, well, that's a win, because that means more time to focus on the other thing. And that's where I see, going back to the bit where I mentioned that I'm serverless subject matter expert. That's where I see more and more customers adopting a serverless first strategy, as in, can we do it in a serverless way so that we don't have to manage infrastructure scaling, and if possible, we just have an API to call? Then let's do that, because it's not a differentiator. If it's a differentiator and we can do it better, makes sense. If it doesn't fit serverless for some reason, then containers is often a second choice. And then if this is not a choice, then instances. And so this result then into a virtuous ops cycle, because by freeing time, by focusing less of the time on keeping the lights on, that means that the tooling team and the people that are helping with the operations on the product teams can focus on improving the reliability, improving the quality of life. And this, in turn, makes you spend less time on keeping the lights on. It's a virtuous cycle. So as soon as you start unlocking that, you start saving time so that you can spend more time on improving things. And finally, just one last bit. One thing that's kind of important to all that process, there is this concept that comes from lean manufacturing that's called undone code. So undone is the Japanese word for paper lantern. And it's a code that people can pull and stops. It alerts that there is a problem and it stops things. But that means that if you have a product team, this product team should be empowered. If you want to give them the responsibility of operations and so on, they should also be able to make call the shots and say, okay, that is not production ready. The business features might be there, but it's not production ready. We should stop here. We should take a step back and think about before we start, selling it. And with that, thank you very much for having me here. And if you have any question, let me know.
Okay, first question.
With the concept that you're applying and we're explaining here, where we divide the product team and the tooling team, how you think the cross-functional or squad tribes will match to similar approach in AWS Cloud? How in that environment where we don't have a dedicated tooling team, we have the team that kind of have everything, it's need to have ops, DevOps, developers and QAs inside of one small squad that delivering the product, the microservice.
Yeah. I mean, the concept of the tooling team is, the tooling team doesn't build product that bring customer value. They build product that bring convenience of life for the product team. But yeah, the product team owns kind of in this model, the product team owns the entire thing. So that means QA, ops, and so on.